Morning, I'm Doug Schmidt. It's great to be here. I decided to change the title of my talk ever so much to reflect what I'd like to convey today, which is what I'm terming Unbinding Prometheus, how generative AI is liberating computing and computational thinking from traditional coding. For those of you who remember your Greek mythology or who read Percy Jackson and the Olympians to your kids when they were little, Prometheus was an immortal who stole fire from the gods and gave it to humans. And that's a bit of what we're going to be talking about today, what generative AI is doing. So there are four things I want to cover today in this talk. The first thing, which is kind of beating a dead horse, is to point out that artificial intelligence is highly transformational. It's disrupting pretty much everything we do. No big surprise. I like to relate this as a tsunami that we either need to learn how to surf or we will be crushed or left behind by it. Second thing I want to be able to cover is preparing us for the coming commoditization of computational thinking, where people without traditional programming expertise can now solve much more complex problems and be able to model systems very effectively. This is the Prometheus piece again. Third thing I want to cover is understanding prompt engineering, both prompt engineering in the large and in the small, is becoming the new computational thinking literacy, where we're shifting from coding in traditional ways with Java or Python or C and so on to prompt guided reasoning. And then finally, to discuss how we can thrive in a world where computational thinkers will vastly outnumber programmers. And this is going to require changes in processes, methods, regulatory approaches, policies, and so on. So let's jump into it. What motivated me to make this presentation? Well, a little while ago, I stumbled upon this diagram from 2006, and this showed the waning and peaking of interest in computer science over the past 30 years. So if you take a look here, in the early 80s, when I was a student at William & Mary, computer science enrollment boomed. Why was that? People thought that if you didn't have a CS major, you wouldn't have a job. Well, it turned out, especially in those days when programming wasn't really that easy, that you could get a job without a computer science major, so interest waned. Then back in the mid to late 90s, you all remember the dot-com boom, where people thought if you didn't have a CS major, you wouldn't be a millionaire. Well, we all know what happened there. So the dot-com boom, we had a dot-com bust, and there was lots of focus on outsourcing. So the enrollment plummeted, and that plummeted for quite a while. Well, I was curious what would happen if we looked over the last 50 years as opposed to that period of time. So what I did is I used my good friend ChatGPT, and I went out and asked it, essentially, can you extrapolate the enrollment trends in computer science over the past 50 years? And I won't go through this now, but if you click on the link there, and you'll all have the slides at the end of this talk, you'll find the ChatGPT session that showed how I did this. And it revealed a bunch of interesting things. You can see things are doing pretty well again. We're back up, enrollment has been climbing. But a big question that many people in the computer science field, and with my dean hat on, I am concerned with this, are asking the question, will this trend continue? Will people still want to be CS majors? And that's a big deal. Something else that this shows is this is a good example of no-code computational thinking. I didn't write a lick of code, I just engaged in a dialogue with ChatGPT and managed to get this wonderful graphic. Now, is this the most perfect graphic in the world? Probably not. If I'd spent another hour or so, I probably could have made it even better. But it wasn't bad for the 5 to 10 minutes I spent on this. I did something similar for data science, which is also something that's emerged over the past, say, decade or so. And you can see that the enrollment is also increasing for data science. And once again, that's a nice example of no-code computational thinking. How did I produce this graph? I used a nice tool called Deep Research from OpenAI. And this is essentially a tool that is an agent that conducts multi-step research by browsing the internet and analyzing various online sources or sources you provide to it in order to give you very detailed citation-backed reports on complex topics. And you can use it for all kinds of fun stuff. Last week I was giving a commencement address at William & Mary for the computer science and data science departments, and I wanted to give it in the form of General Douglas MacArthur's infamous duty, honor, country speech. So when I was driving, I had about a 45-minute drive down to Suffolk, Virginia to meet with some people. So I took out my ChatGPT app and turned on voice mode, and I had a conversation with my chat buddy. And by the time I got back to Williamsburg later that day, I had the first draft of my commencement speech in the form of duty, honor, country. So it was a wonderful example of how you can use these tools to refine your thinking in ways that really would have been impossible to do without spending a fortune on hiring a speechwriter. So if you want to, you can listen to my talk. It was lots of fun. Deep research is basically like having a team of very talented postdocs do your bidding on just about anything. And it is absolutely a game changer for people doing research, product marketing, just about anything you want to do that requires deeper analysis than what ChatGPT will spit back to you in a few seconds if you just prompt it the traditional way. So what is computational thinking and why do we care? Well, computational thinking is essentially ways of being able to apply logic, decomposition, look for patterns, automate, generalize complex problems into parts that can be executed by humans or computers. So it's really not about coding per se, although heretofore most of computational thinking has involved coding. It's really about turning these complex problems into clear, step-by-step solutions that humans or machines can execute. Historically, when people wanted to do computational thinking, they had to learn to program. And that's wonderful. I love to program. If I could spend more time programming, I would certainly do it. I don't have as much time these days as I would like because of the things I'm responsible for. But programming is wonderful. The tricky part, of course, is, first of all, there's so many different programming languages to choose from. And then secondly, there's all these really niggling, quirky, accidental complexities when you start trying to code in traditional languages, especially the kinds of languages people have historically used to build embedded systems, like C or C++. And again, don't get me wrong, I love to program, but it takes an inordinate amount of time trying to wrestle with these issues that have really nothing to do with the domain problem you're solving. You've got to master syntax and semantics. You have to deal with concurrency control, synchronization, fence post errors, the buffer overflow problems, all these kinds of things. And it gets very daunting very quickly. A good analogy is the automotive evolution. 120 years ago, if you wanted to drive a car, you had to know how to build a car. 70 years ago, if you wanted to drive a car, you had to know how to maintain a car. Nowadays, if you want to drive a car, you have to know how to fill it up with gas or plug it in. And as we just saw a minute ago, right now you can go out and order your taxi cab to come pick you up. You don't even have to know how to drive. So that's an evolution over a very long period of time where the details no longer matter to carry out the domain task, which is to get someplace. Likewise, in computing, 70 years ago, if you wanted to use a computer, you had to know how to build the software, probably using punch cards, and sometimes you had to know how to build the computer from the hardware up from scratch. Very complicated and daunting task. 40 years ago, when I was an undergraduate, if you wanted to write software, you had to know how to code in a third-generation language. My first language was Pascal, for those of you who remember that. And you had to know how to debug low-level issues manually. Many computer science departments still teach programming and problem solving in this manner. It's very tragic in many ways. Nowadays, if you want to develop software, you mostly have to know how to install the right libraries, you have to plug in APIs, use frameworks and platforms, basically assembling the software using tools. Again, sadly, a lot of computer science departments aren't teaching people this way of doing things. And that's basically the last decade or so that's really become the paradigm. What's interesting, of course, and we're already seeing this, soon you won't even need to write much code the traditional way. You'll just describe what you want to have happen in some form of natural language, and AI will generate and adapt the solution. And this is actually happening. We'll take a look at a couple of examples here. This is absolutely the way things are going. Radically different from what we used to do, certainly different from what I learned 40 years ago, but I think just as with the automobile, it's letting us focus on the task at hand rather than dealing with what's under the hood. Moreover, nowadays, literally anybody with an internet access and a browser can apply computational thinking by becoming proficient with prompt engineering. Now, there's different flavors of prompt engineering. There's prompt engineering in the small, which basically involves structured interactions with large language models to solve complex problems with natural language by applying prompt patterns. We'll talk more about those in a second. And that's what most of us are encountering today. What's really important, though, for the bigger picture view of people building larger systems and sustaining them over long periods of time is prompt engineering in the large. And we'll talk a bit more about that later. People don't often understand that there's a bigger picture view of prompt engineering, and so right now it's sort of in vogue to say, oh, prompt engineering, it's really not that important. The LLMs are getting smart enough, they don't really have to be explained what to do, but that's missing the bigger picture. Prompt engineering is lowering the barriers to applying computational thinking in both creative and technical fields. And for the low, low price of 3 pumpkin spice lattes at Starbucks, which is about $20, you can get access to pretty much an unlimited amount of very high quality computational thinking and prompt engineering in the form of large language models. If you're willing to spend a little bit more, you can get even more access. So therefore, it's now possible to conduct computational thinking without having to be proficient in traditional programming languages. You can evolve from coding with the lower level approaches in C and C++, which again I love to do, but is often tedious and error prone, up to more modern things like Python and Java, up to using LLMs, and then finally using natural language. In many cases, this way of computational thinking is a lot more appropriate for non-computing professionals. It used to be when I was a professor at Vanderbilt, people would come to me from biology or chemistry, and they would say, we want to apply computational thinking in the work that we're doing. And we'd say, great, we're going to teach you Python, we're going to teach you Java, we're going to teach you, God help us, JavaScript. And they would go away and they'd think, maybe I don't really want to be doing computational thinking after all. The point was they wanted to be doing computational thinking, but they didn't want to have to be programmers. And this approach is, I think, very empowering for people who are not programmers per se. There's a wonderful example, and I don't know if I'll be able to actually access this. Let's see if there's a network that will do this. Well, if this was actually connected correctly, if you go there, you'll see a chat session from me and ChatGPT. And about a year and a half ago, using one of the early versions of ChatGPT, I think it was version 3.5, the first main one that was released, I went to a faculty meeting, and we had each faculty member write down a topic they wanted to discuss. So we had 35 topics. We used ChatGPT to sort them into 7 different groups. And then we were trying to figure out how to allocate faculty to the groups based on their preferences in order 1, 2, and 3 of the topics. Well, my colleague who was helping me organize the workshop was like, let's sit down and do this by hand, and we'll laboriously map the people to the topics to the groups. Or someone else said, let's write a program in Python to do this. And I was like, heck no, let's use ChatGPT. So I sat there, and in a couple of sessions, and if you see the link, you'll see what happened. It went through a couple of passes. The first mapping ended up allocating people, but it used a greedy approach, and therefore some people didn't get the topics that they wanted to have. Typical problem with greedy approaches. So with a few more iterations, it figured out how to do the mapping. It threw in some randomization and used some kind of interesting Hungarian algorithm, and we got the mapping in probably about 5 minutes that would have taken us hours to do by hand. That was my first real exposure to low-code, no-code computational thinking using large language models. And we'll come back and look at that a little bit more later. Even though you don't have to be proficient with programming languages, it helps to be proficient with prompt patterns. For those of you who write software and have written software over the past 30 years, there's been a paradigm called software patterns, which are basically solutions to common problems that arise when you build software in a particular context. And I've written a number of books on this topic. There's a very famous book called the Gang of Four book that many software engineers and software developers would be familiar with. Well, it turns out that there are patterns of prompting just as there are patterns of software development. They're not the same patterns, but they're very important. And they basically codify best practices for phrasing the prompts to the LLMs to get maximum accuracy and provides knowledge transfer mechanisms that will work across different large language models. And we have a paper here that is very widely cited that talks about the concept of prompt patterns. One of my favorite examples of prompt patterns is something called the persona pattern, where you tell the large language model, please act in the role of, say, a senior security engineer, or a reliability engineer, or a regulatory analyst from the FDA, and then do something that will help give me feedback on whatever it is I'm trying to do. And by putting the large language model into that frame of reference, it's then able to use its magic to go find more relevant results. So that's a very simple example, very widely used. There's another paper you can see if you want to learn more about that. So if coding was the key literacy in the 2010s, then prompt-guided computational thinking is the electricity of the future. It's omnipresent, it's indispensable, it's occasionally shocking. And of course, Prometheus would grin and tell us that this is very important, but we have to keep an eagle eye out on important things, especially in regulated domains like trust, safety, and ethics. So we have a tremendous amount of power. How will we wield that power effectively? So let's talk a little bit about how computational thinking is evolving and how it's being commoditized. Tools today are very rapidly evolving to support computational thinking for everybody. In the very same way that search, spreadsheets, databases have become commodities. Everybody knows how to do a Google search. In fact, the most common way for people in my generation to use large language models is essentially a replacement for a Google search. So rather than getting back a list of links, you get back a summary of whatever you asked. And in fact, you simply can't escape LLMs and AI anymore, because when you do a Google search, you now get a summary as well as all the other links, which is kind of funny. Interestingly enough, people who are sort of the 30-somethings are using large language models and generative AI to organize their lives, plan trips, do scheduling of things. And then people who are younger, my son's age, he just graduated from high school, are using large language models as an operating system, where they've integrated that as their primary means of interacting with the digital world. And it is absolutely fascinating to see how powerful those tools are. So if you play around with the pro version of ChatGPT, you'll see that there's lots of different features, services. There's Sora for doing videos. There's something called Operator for doing scheduling and tasks and shopping on the web. And there's about a half dozen different models. With the coming ChatGPT 5, which is supposedly due out this summer, they will go to a so-called magical unified interface, where a lot of those models will sort of be absorbed, and the interface will figure out what you actually need in order to carry out what your task is. More importantly, from those of us who like to write code, like me, large language models are now increasingly embedded into interactive development environments that can translate natural language into code in pretty much any language you want. There's a really neat video, you should go watch this. It's this WindSurf tool. There's other tools like Codex and Cursor and so on that allow you to do coding the traditional way in one part of the window and then prompting in a window that's adjacent to it. This is the way the world is going. There's absolutely no question. We're struggling mightily as a discipline to get everybody up to speed on this, but this is really where the profession is going very rapidly. In fact, OpenAI is in talks to acquire WindSurf for $3 billion, if that gives you any sense of how they view the importance of this technology. So tools like ChatGPT, Claude, Code Interpreter, Codex, to a less extent, Microsoft Copilot, we'll come back to that later. It's kind of the lobotomized version, it's the retail version of large language models, allow computational thinkers to analyze data, generate simulations, write scripts, build interactive tools, basically closing the gap between ideas and concepts and domain-oriented subject matter expertise and the implementations under the hood. There are really three layers of computational thinking that are being commoditized by these emerging tools and platforms. The first is problem abstraction. AI helps to translate vague problems into structured prompts. One of my very favorite things to do with large language models is to start out with a half-baked idea, which I can either talk into my mobile app or I can type, and then it'll quickly evolve to something that's much better fleshed out. And I don't have to spend a lot of time trying to start with a fully cooked idea. I just have to coax it in my interactions to get it to be more fleshed out. From there, we then are able to do automation design, where the AI, the LLM, scaffolds algorithms in using natural language. And then finally, the fun part, where it actually generates the code or does the analysis. And what's particularly interesting, and the examples, a couple examples I showed you so far illustrate this, you can often skip the second step altogether and go from the problem abstraction directly to the implementation. So asking deep research to come up with the graph of the trends of computer science enrollment over the past 50 years. Great example of that. Being able to do what we did where we were doing the mapping of faculty to groups, another good example. Now, under the hood, undoubtedly there's code that's written. The LLM is generating Python code behind the scenes to do the algorithms for those mappings or to do the analysis and the graph production. We never see the code. It's hidden from us. Of course, if you want it to generate the code, it'll do that too. The point of this is that the future increasingly belongs to those who ask the right questions and use AI to model them computationally. Here's a fun example. You can use AI to say, I want you to generate an app that'll entertain my kids because we're going to drive across the country and I want them to learn something, but I want them to be entertained. And so through a very quick series of steps, you can generate a web app, you can generate an Android app, you can generate an iPhone app. All these things that would have taken you, if you could even do it, weeks or months to do is done typically within minutes. There's a name for this that you're probably all familiar with, which is vibe coding. And while vibe coding isn't necessarily the thing I would want to do today to build safety-critical implantable medical devices, might not want to go that far yet, it's something that you can do to whip up prototypes very quickly and then later refine. And there's a wonderful article by Tim O'Reilly who talks about how vibe coding will allow people to explore many different approaches, come up with prototypes rapidly, and then use other tools, other people to be able to turn those into ruggedized, productized apps. And I completely believe he is right about that. Let's talk briefly about computational thinking use cases across disciplines. There are so many places where you can use these tools to get the results without having to write a single line of traditional code. Almost every domain can apply this stuff in all kinds of interesting ways. I went back recently and used the latest version of ChatGPT 03, which is a reasoning model. So it's more sophisticated than the standard model that I used back a couple years ago. And I was able to redo my mapping professors to discussion topic groups. And not only did it do it much more rapidly, but it also has a sense of humor, which may sound strange. If you look at the script, you'll see why it's more funny. But I also told it to generate a visualization of what it had done. So on the left-hand side was the greedy allocation, which left one person out of a group that they wanted to be in. And then they did the backtracking allocation that it came up with to solve the problem with mapping everybody to something that they preferred. It generated the visualization. In fact, pretty much every diagram you see in this talk was generated by AI. So within the last couple weeks, AI has gotten way better at generating diagrams from concepts, and it finally knows how to spell, which is the most miraculous thing of all if you've played with diagramming with ChatGPT. So let's talk about the consequences of the commoditization of computational thinking. And the real point here is just to illustrate that it's not all rainbows and unicorns. There are some very serious things we have to think about. One of the most interesting things is that knowledge work, which is most of what we do, is becoming computational and commoditized at scale. And that is both a blessing and a curse, depending on where you sit in the world. For many years, automation has ended up affecting people doing manufacturing jobs, the so-called blue-collar jobs. And to be quite honest, most academics never really cared about that. People weren't having protests. You weren't seeing people at the academy out with picket signs saying, "Stop automation, it's destroying the manufacturing strength of America." Nobody seemed to care at all. What's happening now with large language models is it's coming after knowledge workers, the white-collar jobs. And all of a sudden, people are a lot more concerned in the academic world, as you might imagine. In fact, they're quite paranoid about this. It's unlikely AI will take your job, although it depends what you do, but it's more likely that someone who knows how to use AI more effectively than you may have a better chance of taking your job. So why does this matter to us? And I use us here very broadly, us as people in higher education and us and people who are beneficiaries of higher education or continuing learning. There was a recent article that said nearly half of Gen Z and millennials think college was a waste of money and AI has already made their jobs obsolete. That's pretty scary for a whole bunch of different reasons. And I'll tell you one thing that worries us and should worry all of us. There's an interesting article that just came out a couple of days ago by an executive from LinkedIn. And his quote was, "I'm a LinkedIn executive. I see the bottom rung of the career ladder breaking." Well, what does that really mean? So let's take a look at what people do today in computer science programs around the country. What we do is we have a lot of people who come out of school with the skills capable of being a junior developer. These are people you wouldn't put on the most difficult project. You probably have them start out maybe doing some testing, maybe doing some simple things. You want them to learn the ropes. But what's happening is that AI is disintermediating people with junior development skills. So when you get out of college with your computer science or data science degree, it may be much more difficult to get hired because companies need people who are much more advanced than that. So what are we going to do about this? Well, one thing we could do is just not do anything and watch our graduates not get jobs. But I think a more effective way to do things is to try to give people the skills through knowledge of prompt engineering, through the knowledge of using these more advanced hybrid tools like WindSurf and Cursor and so on, so that what we're producing are people who are closer to senior developer coding skills. They aren't going to have the domain knowledge, of course, but they at least know how to use all the latest and greatest tools. And we're also going to have a whole bunch of people who are dabblers and software makers who are not computer science majors at all. They're just people who learn to vibe code and do computational thinking with these tools. So the challenge for academics is how do we make junior developers become senior developers more quickly? And of course, AI is a big part of that. How do we make it easier for non-experts to code, using that in quotes, complex software? But even more importantly, and this is where it applies to everybody, how do we let humans and AI work together and interact and grow seamlessly in a trusted way? Those are the challenges that we're confronting right now. Moreover, how are we going to be able to get the tech workforce in the US upskilled fast enough to remain viable in the face of other trends? So I was at a workshop in DC yesterday where we were talking about AI and its impact on education. And you can imagine that DC right now, and Northern Virginia especially, is in a state of chaos because there's a big downturn in people working in the government. Well, there's several things that have come from that. First of all, the workforce has decreased, but the workload has not. And so what we're going to see is the embrace and adoption of automation and AI much more rapidly than would have occurred had the workforce stayed where it was, because people won't have a choice. The other thing that's happening is the government is pressuring the contractors to reduce their software developer workforce by 80%, assuming they can do everything with AI. Now, I think that may be a bit premature and optimistic, but it's certainly the way people are trying to make the world go. So that is going to have all kinds of interesting implications on where people are going to choose to focus in terms of their career growth. There are other issues that we're all well aware of. Hallucinations. What happens when AI becomes a little too clever for its own good and will produce output that doesn't make any sense, but is produced very rapidly and enthusiastically, just like it does everything else. This is obviously a big problem. It was especially a problem with early versions of large language models like ChatGPT 3.5 when used incorrectly and when people didn't actually stop to think about the output. The good news is if you use the newer versions of the tools, if you understand prompt engineering and prompt patterns, and if you apply critical thinking, and one more thing that's really important, if you provide sufficient context to the large language models, the hallucinations drop very, very, very low. I just about never run across hallucinations anymore, and I use these tools every day, all day long, for pretty much everything I can possibly do in my workflow. And it's one of those things like Malcolm Gladwell's 10,000 hours required to become an expert. The more you work with this, the more you know the strengths and weaknesses and the limits. Something else that's super important, and it's related to what I just said, but it deserves mention in its own right. There's a need for metacognitive skills. You need to be able to know when to trust and when not to trust the output from these tools. Trust but verify. You don't want to just take it on faith that it's producing relevant things. So the human is super important in the loop. Computational thinking has never been easier to access than now, but critical thinking and rigor are important to avoid brain rot. By the way, this was another wonderful image generated by AI for me to visualize brain rot. I thought that was pretty cool. There's a whole pile of ethical issues. We don't have time to go into them today. There's a talk that I gave about a month ago that goes into this in great detail. But there's a whole bunch of issues, of course, having to do with copyright, having to do with bias, having to do with over-reliance. A big issue, probably the number one issue that concerns people in academia, is cheating. And of course, there's also the environmental concerns. I'm not going to talk about all those things. I will just mention a couple things really quick. Of course, there's advances in hardware and software that are addressing some of the environmental concerns and some of the other concerns. So, for example, if you're familiar with neuromorphic computing chips, they're basically chips that are able to do AI-style processing, especially inferencing, much less power, much less energy, much less consumption of water to keep the data centers cool. So those are coming into fruition right now. Also, the newer versions of large language models, I'll use DeepSeek as an example, are much more conserving of energy and power, yet still produce very high quality results. So I would not be the least bit surprised that we're going to see a lot better environmental issues over time as people get better at using these tools. Another thing that's important to remember, if you really want to point the finger at what is using energy and water, it's not large language models, it's people who are binge watching Netflix, it's people who are watching 4K videos on YouTube, it's people who eat hamburgers. One hamburger consumes something like 660 gallons of water to keep the cows hydrated. That is vastly more than like hundreds and hundreds of ChatGPT searches. So just make sure you point the finger at the right thing when we talk about the environment. So let's talk briefly about the impact of generative AI on higher education and, probably more to everybody's point here, continuing education. Because in this brave new world of continuous change and the AI tsunami, it's absolutely essential that we continually retrain ourselves. I've gotten to the point where in my day-to-day workflow, everything I do, I start out by asking the question, how can AI make this more efficient? And once you kind of pop into that mindset and you've got the right set of tools at your disposal, it's amazing how much more productive and accurate and fun your work is, because you're able to offload a lot of things that are really tedious and mundane. So first of all, the new computing literacy is not coding per se. It's really about learning to translate human questions into some computational form that supports computational thinking. Should everyone still learn to code? Well, the answer oddly is yes, but not for the same reasons and not in the same way. This is important to recognize, that rather than trying to teach everybody how to be a Python programmer or an R programmer or a C programmer or whatnot, we need to have people think of how to collaborate with AI. So teaching people how to craft thoughtful prompts, that's very important. It's a skill in its own right. Have them learn to critically interpret and verify the output that comes from the AI tools. Increasingly, these tools are going to be invisible. They're going to be calling other tools behind the scenes and using various protocols like the model context protocol in order to do things that integrate seamlessly with all the other parts of your workflow and desktop and team environments. And then apply computational thinking as a foundational literacy. This is something we don't teach at all today. It's kind of shocking. When my son was 15 and he was learning to drive, he had a certified instructor who gave him 30 to 40 hours of in-class instruction, and then he went through 50 to 75 hours of driving on the road with an adult in the car in order to make him a safe driver. If you think about what people do to teach high school kids how to use AI, there's nobody who's certified. Most people are told, don't use AI, you'll go blind. So we discourage people from using it. Kids are afraid, they think they're cheating. And so is it any surprise we're producing people who are actually not able to use this safely? Of course not, because we haven't thought about it in an intentional way. Embrace natural language programming for certain types of tasks. As I said before, not necessarily what you want to do when you're trying to write a pacemaker or a nuclear reactor control system. Not the right place. You could maybe use some of the tools to help you code or do the testing, maybe not writing the code itself or using it in operation, but learning to use things at a higher level of abstraction. Super important to learn the new tools. There's so many great new tools. What's really fun is that I think they're all borrowing from each other very rapidly, the same way that Android borrows from iPhone and so on. And you very quickly will have a convergence of all the tools supporting more or less the same ways of doing things. These are not hard to use. They're very powerful. And the thing I like the most about it is they write the comments for you. So one of the things I'm always trying to teach my students is to learn to comment their code. And of course, nobody likes to write comments. Oftentimes, because nobody likes to write comments, the comments are incorrect. But these tools are really good at documenting things very thoroughly. Another important thing to do is teach learners how to collaborate with AI, not compete with it, not try to fight with it. You can look at this holistically. You can either focus in on certain parts of the software development lifecycle, like the coding part or the testing part, or I think more importantly, you can look at it holistically throughout the whole software development lifecycle. We have a paper that you can get at this link, which talks about how you can apply AI throughout the software development lifecycle at all the different levels. So again, you'll have the PDF version of the slides. You can just click on the links. It'll take you there. For my money, however, I think the most effective place to focus generative AI for current technologies is on the upstream phases, the software project planning, the requirements analysis, the regulatory parts. Why is that? Well, what we found is that code generation and testing is pretty good, but it's not perfect. The gold standard for coding is 100% perfection. If you had a compiler that generated really efficient code, but it was only correct 90% of the time, you probably wouldn't use it, especially in a safety critical situation. Same thing's true with large language models. However, when you start looking at the upstream activities, they're usually producing large documents written by teams of people over long periods of time. And after a document gets more than about 20 pages and is written by more than about 2 people, nobody understands what's in it anymore. And I know this from personal experience. I've worked on lots of safety critical DoD programs where very smart people spent large amounts of time writing regulatory documents for nuclear safe software. And the documents were full of inconsistencies, they were incomplete, they had discrepancies. And this was people who were really, really smart, spending a lot of time. So it turns out that large language models are actually very, very good at detecting document inconsistency, incompleteness, and discrepancies. And in fact, we have a paper, which you can get here, that talks about applying large language models for just that. And if you think about, again, what goes on in large systems, especially in highly regulated markets, you've got to be able to show traceability. You've got to be able to show consistency. And this is something that people can do, but it's hard to scale. Large language models do quite well, and they never get tired. You don't have to feed them Diet Coke and pizza to keep them going. So what can we do to prepare for our AI-augmented future? We need to accept a future where traditional programmers are vastly outnumbered by computational thinkers. And this is going to require a bunch of new approaches to a lot of interesting things. First, we're going to have to rethink the software development lifecycle in a large amount, I think in very positive ways. We're going to have to think about prompt engineering in the large. So most of us today, when we do interactions with large language models, that's us against the world. We're prompt engineering by ourselves. That's not how people build systems. You have teams of people, you have repositories. These repositories live for long periods of time. You have to be able to do versioning. You have to be able to do configuration management. You have to be able to sustain your release-to-release compatibility, all kinds of complicated things. We are at the very beginning of thinking about how to do those kinds of prompt engineering in the large tasks for groups building safety-critical and mission-critical systems. That, in my mind, is really where the world needs to go in the next couple of years, because we really don't have the tooling, the processes, the methods to do that effectively. And then, of course, a big issue with all this fun stuff, especially with vibe coding, is technical debt. So you could write a lot of code really fast that does some really cool things, but God help you to try to maintain that when the large language model changes underneath, which it typically does every couple of minutes, right? Every couple of days. So figuring out how to manage technical debt is going to be a real challenge. So just to wrap up here, anybody here remember King Canute? So King Canute was a Norwegian king who supposedly wanted to show his courtiers the limits of kingly power. So he had them come to the seashore and he commanded the waves to stop rolling in. And of course, the waves completely ignored the king because they didn't answer to kingly power. So going back to the theme of AI as being a tsunami or a tidal wave or just a tide, it's going to be very difficult to will it to go away, even though there's lots of people would like it to go away. It's not going away anytime soon. If you want more information, I have tons of videos on my YouTube channel. I have a YouTube channel with 24,000 subscribers. This is the only thing my 18-year-old son thinks is cool about his dad. It's not PewDiePie level subscribers, but it's not bad. And so I have lots of talks up there. So take a look. There's many other things that we didn't have time to talk about. Thank you very much. Happy to take any questions if we have time.